Alright guys, today we're going to look at the difference of squares today. Alright, so looking at my first part here, let's review how to multiply binomials. Right, we know two methods on how to multiply binomials. You can either FOIL or box them. I'm just going to FOIL these. Remember, if I'm multiplying binomials, we're basically doing double distribution. So I've got 2x times 2x, that's going to give me 4x squared. Multiply here. We've got 2x times a negative 3, it's going to give me a negative 6x. Now I'm done with that term. I've taken that term to both of these. Now I look to my positive 3, and that gets distributed also. So the positive 3 times 2x is a positive 6x, and then 3 times the negative 3 is a negative 9. Now once we're here, we want to combine like terms. So my two like terms are x to the first power. I've got a 6 and a negative 6. When I combine those, they cancel out. So we're left with 4x squared minus 9. Same thing here. I got 3x times 3x, I get 9x squared, negative 15x, positive 15x, and negative 25. Right, so now I want to combine like terms, so the x to the first powers, and we get 9x squared minus 25. So again, my middle term cancels out. Last one, 5a squared times 5a squared is going to give me 25a to the fourth. 5a squared times negative 4b is going to give me a negative 20a squared b. Now we got our positive 4b times 5a squared is going to give me a positive 20a squared b. And then my last terms is going to give me a negative 16b squared. Now once again, we're going to look for like terms. Like term a squared b. You've got 20 and you subtract 20, those cancel out, and we're left with 25 a to the fourth minus 16b squared. Now, if we notice in all three of those examples, my middle terms canceled out. Right? My middle terms canceled out, and I was left with this, which is just an x squared term and a constant. Alright? These are special cases. These are what we call a difference of squares. Okay, a difference of squares. So a squared minus b squared. Okay, we're looking at a squared minus b squared. So we're going to say the factors of that are a plus b and a minus b. Okay, and the key to factoring a difference of squares is that you first have to recognize that you have a difference of squares. Alright, so what does that mean? That means we have the same thing, right, a squared or x squared, and then we have a difference of squares here. So this has to be a perfect square at the end, so b squared. So I have to be able to multiply the same number by itself to get this term here. Same thing here, I have to multiply the same thing by itself to get this term. Now notice my signs. My signs are going to be different. One's going to be a positive, one's going to be a negative. Why? Because you have to have your middle terms cancel out. Alright, so my factors are always going to have different signs. With that being said, if it's a difference of squares, this has to be a minus sign right here. Okay, you cannot have a plus sign, because the only way to multiply to get a negative 9 is with different signs. Alright, so let's look at number 1. Alright, so if this is a difference of squares, I'm looking at what term times what term gives me x squared. It has to be the same term, right? This is the difference of squares, meaning it has to be the same thing in both of these parentheses. Well, we know that x times x gives me x squared. Now, going by our little formula here, one's going to be positive, one's going to be negative. Now I need to figure out, again, what is the same number that I can put in both of these parentheses right here to multiply together to give me 9. It's got to be the same number. Well, we know 3 times 3 gives me 9. So we just completed our difference of squares. X plus 3x minus 3. Now, you can always take this and multiply it back out and see if we get this answer. Okay, so if I was to FOIL this back out, we've got x times x, that's x squared. We've got a negative 3x, a positive 3x, and a negative 9. So my middle terms are once again canceling out, and we're left with x squared minus 9. So we can always take our answer, FOIL or box it back out, and get to our original quadratic. So we're doing the opposite. Okay, we're doing the opposite of FOIL and box. which is what we call factoring. We're going to factor a difference of squares. All right, so if I go to number 2's got a, right? So nothing changes. I still want my first term to multiply to give me a squared. It's got to be the same term. So we know it's got to be a times a to give me a squared. And again, if it's a difference of squares, I know my signs in my parentheses are going to be opposites. One's positive, one's negative. And now we're looking at what number times itself gives me 36. It's got to be 6. Again, if I'm unsure, let's FOIL this back out and make sure we get this answer right here. All right, let's hop down to number 4. Now, number 4 is a coefficient in front of the x squared. So same thing. I want to know what term times what term gives me 4x squared. It's got to be the same term. So what number times what number gives me 4? It's got to be 2 and 2. And what variable times what variable gives me x squared? It's got to be x and x. So this term times this term's got to give me this. 2x times 2x gives me 4x squared. Fantastic. Now it's a difference of squares. And we notice that because this is a perfect square, this is a perfect square. Well, what number times itself gives me 25? It's got to be 5 and 5. Because 25 is a perfect square, what we call a perfect square. And what that means is that this number times itself, 5 squared, gives me 25. All right, let's hop down to, let's go to number 5. All right, number 5, we got 9y squared minus 1. So once again, first term times first term has to give me 9y squared. So I'm going to get a 9. How do I get a 9? It's got to be 3 and 3. I need to get y squared, so it's got to be y times y. So 3y times 3y gives me 9. Y times y gives me y squared. Now I've got to multiply to get a negative 1. It's got to be the same number multiplied by itself to get a negative 1. We know it's got to be one's positive and one's negative, because the only way to multiply to get a negative is with different signs. And then what number times itself gives me 1. Well, it's got to be 1 and 1. All right, let's go to number 8. Number 8, I've got 25x squared minus 9, right? So I'm going to look for my two first terms have to multiply to give me 25x squared. So this has to be a perfect square for this to work. Is 25 a perfect square? Absolutely. 5 times 5 gives me 25. Is x squared a perfect square? Yes. X times x gives me x squared. Now look to 9. Is 9 a perfect square? Yes. 3 and 3. And we know one's got to be positive, one's got to be negative. All right, let's go to number 9. Number 9, I've got 4x squared plus 81. So we can set up our parentheses. 4x squared plus 81. Okay, well, what do we notice that's different from number 9 than all the other 8 that we have looked at? Minus, 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 minus. That's a plus sign. Okay, so let's go ahead and try to continue and work this just like we've been doing. I need my first terms to multiply to give me 4x squared. So number times number gives me 4. It's got to be 2 and 2. 4 is a perfect square. X squared is a perfect square. X times x gives me x squared. Now we've got to multiply to get a positive 81. Okay, well, if you multiply two positive numbers, 9 and 9, you get positive 81. You're absolutely correct. But the problem is, when you FOIL this out, you get 4x squared plus 18x plus 18x plus 81. So when you combine like terms, this gives you 4x squared plus 36x plus 81. Your middle terms don't cancel out. So if you have a plus sign right here, it cannot be a difference of squares. It has got to be a minus sign to be a difference of squares. All right, let's look at number 12. Number 12, we got 64x to the 4th minus 1y squared. Okay, no big deal. I need to multiply a number times a number to get 64. Well, 64 is a perfect square. 8 times 8 gives me 64. I need to multiply a variable times a variable to get x to the 4th. It's got to be the same variable. Okay, well, instead of it being x, like we've been doing, or y, I've got to multiply x squared times x squared to get x to the fourth. Now, I've got a minus sign. Fantastic. One's positive, one's negative. I need to multiply to get this number, so 1 times 1 gives me 1. And I need to multiply two variables to get y squared. Well, it's got to be y times y. All right, let's flip our paper over. Let's go to number 13. Now, number 13, I notice in both of these terms that those are both divisible by 8. So going back to yesterday, we can factor out our greatest common factor. So 38 divided by 8, that gives me 4x squared, minus 8 divided by 8 gives me 1, so we're left with y squared. Now, this is a perfect square, difference of squares. So this is going to be 8. And I'm looking at what term times what term gives me 4x squared. So it's got to be 2x times 2x. And then positive, negative. And I need to multiply two terms to give me y squared. It's got to be y and y. Bam. There you go. What about number 15? Okay, number 15, I have a greatest common factor here. All right, I can factor out 4. 100 divided by 4 is going to give me 25a squared. Minus 144 divided by 4 is 36. Now we're looking at difference of squares here. 25 is a perfect square. 36 is a perfect square. So that 4 stays outside, and now we're going to factor our difference of squares here. 5a times 5a gives me 25. a times a is a squared. Now I need different signs. And 36 is a perfect square. 6 and 6. Bam.